One of the greatest strengths of computers is their ability to rapidly analyze large amounts of data. Often, the data a program will analyze comes from external files, in particular, files such as spreadsheets or databases that hold data in a tabular form consisting of rows and columns. Each column typically has a name associated with it, describing the information held in that column. For example, a file named emissions.csv could hold a spreadsheet containing the information from a climate study that collected emissions data from various countries, including the name of the country, the year the data was collected, the amount of carbon dioxide emitted, and the amount of methane emitted in that year. The spreadsheet containing the data could have 4 columns named country, year, CO2, and CH4, and the rows would contain the information for a given country in a given year. Such data files are typically held on some form of permanent or persistent storage device, meaning that the file will continue to exist even if the program manipulating the data ends or the computer holding the data is turned off. Examples of persistent storage locations include a hard disk, an external disk, or cloud storage. However, there is a problem. When a program is running, it is held in the computer's memory, and it can only directly access and manipulate data that is also held in the computer's memory. It cannot directly access and manipulate data in a file on a storage device. So, if a program wants to use data that is not held in memory, such as data in a file that is stored on the hard disk, that data must first be copied from the original source into the computer memory so that it can be accessed and manipulated via variables in the program code. This action will create 2 completely separate copies of the data file, and changes that occur to one copy of the data will not automatically occur to the other.
Since analyzing data that is stored in a tabular form is so common, many programming languages provide a particular type of variable, called a data frame, that holds information in a tabular form consisting of rows and columns. This format directly reflects the format of the information held in spreadsheet and database files. The data that is held in a spreadsheet or database is copied into a data frame variable in computer memory so that the program statements can access and manipulate it. However, it is important to remember that the program is not accessing the original data, but the copy held in the data frame in the computer memory. If the program changes the values in a data frame variable, for example, adding or removing rows or changing individual values, those changes are being made only to the data in the data frame variable in memory, not to the original spreadsheet or database. If the program makes changes to the data frame but ends without copying those changes back to the original file, those changes are lost when the program ends, in which case the file maintains its original contents. If those changes need to be saved to the original spreadsheet or database, the program must execute statements to explicitly copy the changes back out to the original file in order to update its contents, ensuring that the changes persist even after the program ends. Programming languages provide statements and functions to copy data back and forth between a data frame and the original file, as well as commands and functions to access, analyze, and change the information in data frames. However, the first step to these manipulations is to copy the information from the original spreadsheet or database into a data frame variable. So the program would first use a function like readSpreadsheet to copy the information in the file into memory. Such functions take the name of the file containing the tabular data as a parameter. When the function executes, it copies the information from that file into memory and then returns the memory address where that data is located as the result of the function. That address can then be assigned to a data frame variable, which will then be used by the program to access the data. As an example, assume a program wants to analyze the emissions data from the spreadsheet held in the file emissions.csv on the hard drive. The program could use a statement like, emissions data is assigned read spreadsheet parenthesis emissions.csv closing parenthesis. This statement creates a new data frame variable in the symbol table named emissions data. The function readSpreadsheet then copies the spreadsheet data from the file emissions.csv on the hard drive into computer memory and returns the memory address where the data is located. That address is then assigned to the variable emissions data. Since the value for emissions data held in the symbol table is not the actual spreadsheet data, but rather the address where the data is located in memory, it is represented visually as an arrow pointing to the data frame. Using the operations and functions provided by the programming language, the program will then use the data frame variable, emissions data, to access and manipulate the copy of the spreadsheet data that is in memory. Some programs will only examine and analyze the data in a data frame without changing it. However, if a program changes the data in a data frame, those changes will be lost when the program ends unless a command is executed to explicitly copy the information in the data frame back to the original file on its storage device. Programming languages provide functions to write the current values in a data frame back to such devices to preserve the changes. For example, a statement such as write to file, parenthesis, data frame variable, comma, file name, closing parenthesis, will copy the values in the specified data frame variable to the specified file on a persistent storage device. If the file name specified in the command is the original file name, the command can be used to update the original file with the changed values in the data frame. However, sometimes it may be desirable to preserve the original file contents and create a new file to hold the changed data. In that case, that new file name would be used in the write to file command to copy the data frame values to the new file, preserving both the original file contents and the changes made by the program. Returning to the emissions example, assume that the CO2 emissions in the first row had been changed by our program to 3 million. If the program ended without writing back the data frame, that change would be lost when the program ended, and the file on the hard disk would maintain its original value of 3,010,000. However, if the command write to file emissions data, comma, emissions.csv was executed, the changes made by the program to the data frame variable emissions data would be copied back to the original file, emissions.csv, updating its contents and preserving the changes made to the data frame by the program, even after the program ends. Check out the commands in your programming language for copying data between data files and data frames.
Let's review our key points. Data, such as spreadsheets or databases, that are held on persistent storage devices cannot be directly accessed by a program. Their contents must be copied into memory in order for a program to analyze and manipulate the data. Data frames are a type of variable designed to hold tabular data, such as spreadsheets and databases, that is organized in rows and columns. Changes to data frames are not automatically saved in the original files. An explicit statement must be executed by a program to copy the current values in a data frame back to the original spreadsheet or database file if those changes need to be preserved in the original file. If an explicit statement is not executed by a program to copy the current values in a data frame back to a file on persistent storage, any changes to the data in the data frame will be lost when the program ends. Programming languages provide operations and functions to copy information between data files and data frame variables, and to access, analyze, and manipulate information held in data frame variables.